My name is Scott Kishbaugh, and I'm an environmental engineer with the DEC Division of Water. A little bit of background before we get started. As Leslie may have indicated in some of the previous presentations or inevitably in some of your interactions with the agency, many of you know that invasive species activities are spread out among a bunch of different divisions in DEC. Historically, aquatic plants have been dealt with through the Division of Water where I work, while issues related to invasive animals have generally been dealt with out of Division of Fish and Wildlife. Now that there's a new Office of Invasive Species, many of those activities will ultimately be coordinated. So this will essentially be a presentation from kind of the old school of Division of Water's activities related to invasive plant activities. And what I'm going to take you on in the next 30 minutes or so is a whirlwind tour of the 10 worst invasive exotic aquatic plants in New York State. This is largely on an article that I wrote for the Long Island Botanical Society a little more than a year ago. And since then, I've discovered a number of things. First of all, when I've gone through the list, it really isn't 10. It's more like 12. Many of these plants that we're talking about may not, at least at this point, really be considered invasive, although many of them are exotic. Some of those that are invasive may not technically be exotic, so we'll talk about that a little bit later. So I'm going to change the name of the talk. I'll call this the Dirty Dozen, the 12, give or take, aquatic plants that you don't want to have in your lake. And what I'm going to do is talk about these 12 plants from the country of origin through which they ultimately entered this country. Generally, when we're talking about invasive aquatics, we're talking about exotic plants, much like a cactus would be in the North Pole. We'll talk, first of all, about the plants that come from Eurasia, the Europe-Asia area. The first and perhaps one of the most prominent invasive aquatic exotic plants in New York State would be water chestnut. The introduction to the United States is still somewhat subject to disagreement. Most consensus seems to suggest that the origin into the United States was around 1874, probably in one of the ornamental ponds or herbaria associated with Harvard University. For many years, people believed that the introduction into the United States was also the introduction into New York State into a small pond just uphill from Collins Lake in Scotia, New York, when there was a significant rain event, the water chestnut, which was introduced ornamentally by the landowner of that particular pond, resulted in the water chestnut spilling into Collins Lake, which is only about a mile from the Mohawk River, and hence the spread of water chestnut in New York State began a little more than 125 years ago. For each of the plants that we'll talk about, I'll break them out into a bunch of different categories just to give some context for, again, the plants that we're talking about. As many of you know, water chestnut is a floating leaf plant. It has a pinnate submersed leaf, as you can see from the line drawing on the right of this illustration. It looks a little like a number of the other plants that we'll talk about, particularly the milfoils in the submergent portion of the plant. The floating leaf portion of the plant has a rosetta of leaves, a palmate leaf structure that has individual triangle-shaped leaves and a serrated or toothed leaf margin. The map that's on the upper right of this plant summary and all of the plant summaries that I'll talk about come from a database that has been maintained by Larry Eichler from the Darren Freshwater Institute, which pulls in aquatic plant verifications from a number of different sources over the last 15 years or so. When you look at a number of the other inventory mapping programs that are out there, you'll see some of them are broken out by counties, some of them are broken out based on other historical records, and one of the things that I'll talk about a little bit later, as has been talked about, I'm sure, in conference calls in the past, is the need to try to consolidate as many of these databases as possible. But for the starting point, I'll work off the same database for all of these plants. And this shows individual verifications of these plants in various parts of New York State. The habitat for water chestnut tends to be in the shallow, sluggish portions of rivers or lakes, generally in muddy sediment areas. The growth characteristics of this plant is that it tends to form very dense surface mats and a canopy associated with those mats. And the competitive advantage that this plant has, and each of these plants has some competitive advantage that allows it to thrive in certain environments, is again the characteristics that we just talked about. Many of the aquatic plants that we see in New York State don't do very well in shallow or sluggish water. They tend not to grow very well in mucky sediment, and this plant, like a few of the others that we'll talk about, form a very dense surface canopy that crowds out sunlight, eliminates many of the plants that grow underneath it, and allows the spread of the plant laterally across the sediment. The picture shows what the water chestnut looks like from a view above. The bottom picture shows what water chestnut has looked like on portions of Lake Champlain. It's been controlled in a number of different ways in New York State. The most common techniques have been harvesting programs, either with the use of large mechanical barge-driven harvesters or hand-cutting operations. Herbicides have been used for controlling it, primarily 2,4-D historically. Glyphosate can be used for water chestnut control, or it has been used for water chestnut control when you have very dense surface canopies of it. And it shows a list on the slide as well of a number of the lakes in which this plant has been controlled. The next on this whirlwind tour is Eurasian water milfoil, also Eurasian introduction. We believe that it came into the United States and in New York State in the 1940s. It's a submergent plant with a similar pinnate submerged leaf structure like we see with the submergent portion of the water chestnut. It does not have a floating leaf, however, it has a fluorescent spike that's found above the water surface. There's a whorled leaf arrangement, meaning that the leaves originate along the stem in a whorled structure, generally in groups of 3 or 4. It's a thread-like leaf with a smooth margin. As you can see from the map, it is in New York State. We found it pretty much everywhere, every county or every relatively large area on the map to the upper right that you don't see Eurasian milfoil. It's probably because we haven't looked hard enough for it there yet. One exception to that may be the eastern portion of Long Island, where we have done some fairly extensive surveys and have not yet found it. However, just in the last 3 years, we have verified Eurasian water milfoil in Long Island. It has a number of different competitive advantages. It is highly adaptable. It grows in a wide variety of circumstances, generally from 3 to 12 feet in depth, but it can grow shallower than that. We've seen it growing in 25 feet of water. The primary characteristic of the plant are dense surface canopies and mats and a large submergent, what I'll refer to as architecture, a lot of plants growing within the water column, a large, dense column of plants. It's an opportunistic generalist, meaning that it grows in disturbed environments and it grows in a wide variety of circumstances, hence the generalist characterization, and it autofragments. The plant produces primarily by fragmentation that can be created by boat traffic, by a number of other mechanisms, but within its natural growth cycle, it will also autofragment, meaning that even if you don't do anything to spread the fragments, they will spread on their own. It is probably the most extensively controlled plant in New York State, but you could see from the map on the previous slide, many of those attempts have not been very successful. Many of the techniques that you see on this list have been adapted specifically to try to control this plant, and there's a large number of plants, a large number of lakes that have been the subject of active control projects. Some moderately successful, some not at all. Curly leaf pondweed is another Eurasian plant coming into the United States in the early 1880s and probably shortly thereafter in New York State. We have not been able to track exactly when and where it came into New York State, probably in the Finger Lakes region, but that's not really well known. Also a submerged plant. It has a ribbon leaf plant. The best description that I've seen of the plant is that it looks like lasagna. It has a curly margin and a curly leaf, hence the name curly leaf pondweed. Also has a floating spike, no floating leaves associated with this pondweed. It is one of about 30 different potamogeton or potamogeton species within New York State. It is considered to be only one of those that is exotic. All of them are characterized by alternating leaves and it has an oblong leaf shape with a rounded tip. You can see from the inventory that we have in the state, it is growing extensively in the state as well. You'll notice a fairly wide swath corresponding to Mohawk River, Erie Canal, and the Finger Lakes region. It's likely that a significant vector for the spread of this plant, like a lot of the other plants we're talking about, has been the canal system, boat traffic, and boat movement from one water body to another. Like many of the other plants, it tends to be a generalist. It can grow in a variety of depths. It generally tends to prefer rocky and sandy sediment. Its competitive advantage corresponds to its growing season. It's a plant that starts growing under the ice, generally tends to peak in May and June of each growing season. In the northern temperate climates, it tends to disappear from the water column. It tends to senesce sometime at the end of June to early July. In recent years, we've seen that growing season expand, probably due to global warming. It spreads by a number of different mechanisms. It's also one of its common techniques for spreading is the development of an overwintering turion, an overwintering bud that will float up on the surface of the lake or other water bodies and will eventually become waterlogged, drop down to the bottom, and create the next generation of its growth. The lasagna picture in the upper right, the bottom right shows a picture of what that plant typically looks like in the water column. Over the next couple of weeks, if you get out to a water body that has Potamogeton crispus, you'll probably see it growing. It's already growing fairly extensively in many lakes. It's been controlled by a number of different mechanisms: mechanical harvesting, dredging, herbicides, and grass carp, and you can see the list of lakes where it has been the target of aquatic plant management activities. The next to consider is a plant from, we believe, Asia. There's some evidence that it may have also had a European origin. Yellow floating heart, Nymphodes peltata. The line drawing on the upper right shows a picture of the plant. I'll show some better images in the next few that shows what the leaf and the flower looks like. Originated in the United States, we believe, in the 1880s in Massachusetts. We don't really know, or I haven't been able to find any good information about when it was introduced into New York State. We believe it was introduced into Lake Champlain, where it's found most predominantly in New York State, in and around the 1950s. A floating leaf plant with no submerged leaves, floating heart-shaped leaf that's shallowly scalloped. You can see the image on the right showing the counties in which it's been identified, the two northern ones associated with, again, the Lake Champlain region, South Lake Champlain in particular, and some other places in the state. Like water chestnut, tends to grow in many of the same kind of environments. Shallow water, mucky to sandy sediment, also forms very dense surface mats. And like many of these surface-forming plants, its competitive advantage comes primarily from light limitation and its ability to grow in relatively turbid water. See the two pictures of what the plant looks like, a lot like water lilies. The smaller yellow leaf is what, from a superficial standpoint, distinguishes the plant, though when you look at it up close, the leaf structure is a little bit different. I'm not aware of any control activities that have been performed for this particular plant, though inevitably it may have been controlled in the midst of trying to control other plants in a lake. The next plant that we'll look at is a European origin plant called brittle naiad, or Naias minor. I believe it was introduced into the United States in the 1930s, and it's in New York State probably in the 1940s. Submerged plant that has thread-like leaves and no floating leaf, thread-like submerged leaves and no floating leaf. Like the naiads, all the other naiads, it's an opposite leaf arrangement with, again, a threaded leaf, but the way to distinguish this plant from the other primarily native naiads is the coarsely serrated edges. The best description of this plant, at least the way it feels, is a Brillo pad, very sharp, scratchy plant. The maps that you see on the upper and lower right correspond to its distribution in New York State and in the United States. I'm certain that the distribution of this plant in New York State is greater than this. This is a plant that hasn't really been on the radar screen until the last few years, and it does look in some lakes, particularly in some saltwater lakes, a little bit like many of the native naiads. So it's very possible that a plant that was identified just as a naiad, not identified down to species level, was actually Naias minor, and therefore should show up in this distribution map. I suspect we'll fill in this map far more extensively in the next couple of years. It tends to grow in relatively shallow water, but we've seen it growing in 8 to 10 feet as well. It tends to grow in sandy and mucky sediment. Its primary competitive advantage is that it's what I'll refer to as a post-disturbance pioneering plant. We've seen this plant come in a lot of lakes that have been controlled for other plants. A good example is a lake in the Albany area in Rensselaer County called Snyder's Lake that had extensive control of a Eurasian water milfoil population. This plant, there was no evidence that the plant had been found in the lake prior to this, but within 2 years after the control of the Eurasian milfoil, this plant was growing extensively throughout the water column from depths of about 4 feet to about 9 feet. And it was growing so densely that it was impossible to snorkel through it. And I can tell you that because I attempted to do it and ended up cutting myself up pretty extensively in the process. It tends to grow in bushels. This is what the plant looks like in the upper right. If you look at it closely, you can see these fine serrations on the individual leaflets. Again, it was growing so extensively in Snyder's Lake that they ultimately had to control it with the use of a contact herbicide, a spot control in the areas where it was growing most extensively. Moving from Europe to Canada, we'll look at European frogbit, Hydrocharis morsus renee. It's a floating leaf plant with no submerged leaf and an ovate or heart-shaped leaf, floating leaf structure. It has a smooth margin. Again, the distribution map is probably somewhat more extensive than we show here. It's shown along the St. Lawrence River Basin and in Lake Champlain. It's been found along the wide edges of rivers and lakes. It tends to form very dense tangles, and like many of these other surface-dwelling plants, it tends to shade out and create light inhibitions for many of the other plants, allowing its lateral spread. Picture of what the plant looks like in the upper right, and the lower right, a somewhat more distant view of how extensive it can grow up along the surface. It is the target of one of the new invasive species grant projects on the Grass River in the St. Lawrence region via hand harvesting project. Moving to South America, we'll look at Brazilian Elodea Egeria densa. We know the introduction of this both into the United States and in New York State, in Mill Neck, Long Island in 1893. Another submerged plant. It has a ribbon-like leaf. It will flower, though we don't see that very often, at least in New York State. It has a whorled structure, like the milfoil does, though a ribbon leaf rather than a pinnate leaf structure. The whorls tend to be in numbers greater than 4. One of the other plants that I'll talk about a little bit later looks very much like Brazilian Elodea, Hydrilla. A third plant that looks very much like the two of those is common waterweed, or Elodea canadensis, perhaps the most common submergent aquatic plant that we found in New York State. Superficially, they look identical to each other. One of the ways that you can distinguish those three plants is the number of whorls. The common waterweed, the Elodea canadensis, tends to be found in whorls of 3 or fewer, where both the Brazilian Elodea and the Hydrilla tend to be found in whorls of 4 or more. There are other characteristics to distinguish those, but that's a good initial starting point. That said, because Elodea canadensis, the common waterweed, is so common in New York State, it is possible that both the Brazilian Elodea and, we hope not, but potentially the Hydrilla may have been misidentified as common waterweed historically, again, because it was such a common plant, and because both of these plants have very quickly moved to the top of our radar screen, sorry for mixing analogies there, become a very, very high-profile plants. We've been obviously looking more carefully at these. This plant is also finely serrated. At present, we believe that the distribution of this plant has been limited to the southern part of the state. We found it more extensively than we expected in Long Island in recent surveys over the last few years. It's also been found in a couple of water bodies in Orange County in the last few years. It has been found in a variety of habitats. In Long Island, typical of the lakes in which it was found in shallow water, but it was found in much deeper water in Orange County. And there are a number of other plants that are like this, that they have one growth characteristic in a certain type of water body, and then when they get introduced into a new water body, they adapt somewhat new growth characteristics. It tends to form a dense bottom cover and can form pretty significant surface tangles. As was indicated in this move from Long Island up the state, it tends to be somewhat more adaptable to cold water environments. This is a plant that was historically limited to the southern part of the country and has been moving north and been adapting to these cold water environments. Like many of the other plants that we've been talking about, it tends to move by fragmentation. This is an image of what the plant looks like. If it looks very much like a plant that you can buy in many aquaria stores, you're absolutely right. This is a plant that has been sold in the aquaria trade for many years. As far as I'm aware of, there have not been any control projects, though this lake in Orange County, Lake Guymard, is likely to be looking to control this plant within the next year. Another South American plant is parrot feather, Myriophyllum aquaticum, one of about 8 to 10 Myriophyllum species that are found in New York State, most of which are native, a few of which are considered rare, threatened, or endangered, but 3 of them are on our watch list, or our list of concern, and this is one of them. This plant was introduced into the United States probably in the 1890s and shortly thereafter in New York State. Submerged plant, though it has a pretty significant floating spike that is essentially an extension of the submergent portion of the plant that falls above, that you can be found above the water surface. Like the other milfoil plants, it has a pinnate submersed leaf structure and a whorled leaf arrangement. Like the other milfoils, it tends to have a threaded leaf with a smooth margin. You can see from the distribution map that its growth in New York State has been limited to Long Island, one lake in Suffolk County, and a few lakes in Nassau County. Tends to grow in shallow water environments. It has a lime-colored emergent tip that I'll show you in a second, and subsurface has individual stems. When you see these plants grow up on the surface, they tend to look fairly crowded, but when you look at the individual plants, you can separate out the individual stems. Also tends to be adaptable to cold water environments, and like all the other milfoils, tends to move very easily by fragmentation. The picture on the bottom right looks very much like what you would see sticking up on top of the water surface, a lime or bright green colored, fairly rigid stem plant, unlike many of the other milfoils. Most of the other milfoils, the emergent portion of the plant tends to look a little bit like a pipe cleaner spike. This looks very much like the leaf structure of the plant that's underneath the surface. You can see in the upper right what this plant ultimately can look like sticking up out of the water. I'm not aware of any of the lakes for which we found this plant to be controlling it. Floating water primrose, Ludwigia peploides, is another South American plant. There is some evidence that it's native to New York State, or to the United States, or at least it has become naturalized, though I don't believe there's any evidence that it's native to this state. We believe the introduction in New York State was in 2003. The plant type is floating. It has a floating rosetta, flowered type leaf. The leaf arrangement is alternate, an elliptical leaf shape with a smooth margin. It has been, as far as we know, it's limited to 2 occurrences in New York State, one of which I'll talk about in a second. Tends to be found in open marshes or the quiet edges of rivers and lakes, again, typical of a lot of floating emergent leaf, emergent or floating leaf plants. Also tends to form dense tangles, and like many of these surface plants, tends to be gaining a competitive advantage through light inhibition or shading. This is what the plant looks like. It is another one of these plants that has been the subject of one of the new invasive species grant control projects in the Aquatic River in Suffolk County. And you can see what the plant looks like when it's growing up on the surface. Moving into this country, in terms of the origin of the plant, Kishbaugh caroliniana, or fanwort, originated in the southeastern United States. It is native to the United States, but not to New York State, where it was introduced, we believe, in the 1940s. A submergent plant that, again, like the milfoils, would have a pinnate submerged leaf type. It has a small floating flower, and many of the plants that we found in New York State are flowering. It has an opposite leaf structure, you can see from the line drawing. Plants coming, the individual leaflets coming out from opposite sides of the stem, a thread leaf shape, and a smooth margin. For many years, we believe that the distribution of this plant was limited to Long Island and would be, because of habitat, solely limited to Long Island, but as you can see from the map, it's popped up in lots of different places. The place where it first showed up, at least on our radar screen outside of Long Island, was a group of 4 lakes in the southeast corner of the Adirondacks in Saratoga County. In Long Island, it was found growing primarily in shallow water up to the surface, generally in water less than 6 feet deep. In these 4 lakes in Saratoga County, or in 3 of the 4 lakes in Saratoga County, it was found growing in 22 feet of water, growing 10 feet tall, and not within 10 feet of the surface. Acres and acres and acres of it found in the bottom of these lakes. So, like many of the plants that we've talked about earlier, and one of the lessons that comes out of this is many of these plants are very adaptable. It spreads by fragmentation by a lot of these plants, spreads by fragmentation like a lot of these other plants, and it creates this significant subsurface busheling, like you could see in the picture in the lower right. There are probably 2 different forms of this plant that we find in New York State, one called the red form and the other called the green form, and they behave very differently, or at least respond very differently to control techniques. Some herbicides work better on the red form than the green form, for example. It's been controlled by a number of different control strategies in New York State, and you can see the list of the lakes in which one or more of these techniques have been attempted. Another plant that we believe is native to the United States and may or may not be native to New York State, we're not really sure, is one of the other milfoil species, Myriophyllum heterophyllum, or variable water milfoil. It's another submerged type plant, and like many of the other milfoils, like all the other milfoils, pinnate submerged leaf structure, whorled leaf arrangement, thread leaf, smooth margin. Another one where the distribution map is probably not complete, has not been a high-profile plant until relatively recently, where we've started to see some fairly dense populations of this plant in the Adirondacks and in Long Island. It can form very thick surface canopies, as thick or in some cases even thicker than Eurasian water milfoil. And in many of these lakes, it's characterized by a very thick stem that you can see in the picture in the upper right. It is by far the thickest stem of the Eurasian milfoil plants and among the thickest stems of any submergent plants we've ever seen. These stems can be sitting right up on top of the surface of a lake or a poorly flowing system. I can tell you from personal experience, taking a canoe on top of these, it will actually hold a canoe up and you can't move it. Very extensive growth. Another native plant to the southeastern United States and potentially to New York State is swollen bladderwort, which I think takes the prize for perhaps one of the most aptly named invasive plants. If that doesn't sound like the name of an invasive plant, I couldn't tell you a better one, except for maybe rock snot. It is a submerged plant that has, like many of the other bladderworts, hence the name bladders. It has a rather unique floating structure, which is better seen than described, but essentially it looks like a wheel platform, and I'll show you a picture of it in a second. Smooth margin, thread leaf, and it's a basally forked herb. Another one of these plants where the distribution is probably greater than we're showing here, though it's a plant that tends to grow in weakly acidic soft water lakes, so its distribution may be limited by its growth characteristics. It's considered endangered in some places. However, we've been seeing it growing extensively in some places in the Adirondacks. This is what the plant looks like when it's growing up on top of the surface. You can see the flowering, the yellow flowers, and this pinwheel structure that's right up on top of the surface. Another plant that we're not really sure why it has gained this competitive advantage over a lot of other plants, but it is growing far more extensively in the last 10 or 15 years than we have any historical records of. So it's one that may really fit in the category of a nuisance plant rather than an invasive plant, but it's one that warrants being on the radar screen for people. So that was the 12 plants that we believe are the most extensive exotic aquatic plants in New York State. However, we would be remiss if we didn't mention at least one other plant that you definitely don't want to have in your lake. So I'm changing the name of the talk again to the Unlucky 13. And that plant is hydrilla. We have not yet found this in New York State. That doesn't mean it isn't here. Again, as I mentioned earlier in the discussion with Brazilian elodea, it looks a lot like both that plant and the common waterweed. So it's possible that this plant may be in New York State and we just haven't seen it yet. It has the same characteristics that I talked about with the Brazilian elodea. We believe it was introduced in the United States around 1980, probably in Florida. It has this whorled leaf structure, and like the Brazilian elodea, is found with a much larger number of whorls, typically 4 to 8. If you look at the line drawing, the individual leaflet picture, you see these spikes, sawtooth edge, and these spikes that are on the underside of the leaf. When this plant has been found in New England, we have not seen these spikes, even though it is a characteristic of the plant as it grows in the southern part of this country. So that certainly indicates that this plant may be adapting its growth in the Northeast, but it may be that and some of the other standard tools that we've used to try to identify this plant may not be accurate, hence confounding things even more. Again, it is not found yet in New York State, so you could say that we've created a fence around New York City and the rest of the state to prevent its introduction to the state, but I really can't say that we've been that fortuitous. Either it hasn't gotten here luck, or it just hasn't gotten on to our distribution list because we haven't positively identified it yet. It is clearly coming. The distribution map that I show on the bottom right is from a few years ago. Since then, it's been found in Maine and New Hampshire and Massachusetts, Connecticut, I believe Rhode Island, and in New Jersey. And we know it's been found historically in Pennsylvania. So it's around us, and it's ultimately coming. This is what the plant looks like. If it looks a lot like Brazilian elodea, you're right. Many of these plants look very similar to each other. We have no history of controlling it in New York State because we don't yet have it in New York State. I'm going to change the name of the talk one last time. We have the next generation of aquatic plants that we need to be concerned about. And this talk could go on for hours and hours and hours talking about all of the other exotic plants that have been found in other parts of this country that are working their way into New York State, and other plants that have been found in other countries that we know can adapt to our environment and have just not been identified or found yet in this country, but we know they're coming. I'm just going to focus on a couple of them. One that we know is in New York State already, and I didn't include in our original Unlucky 13 because it's not a macrophyte. It's not a true rooted vascular aquatic plant. This is starry stonewort, our Nitolopsis obtusa. That is actually a macroalga. It's a submergent plant that grows in submerged filaments. Its leaf arrangement, if you want to call it that, is these uneven angular joints, and I'll show you a picture of it in just a second. It has a smooth margin, unlike some of the other stoneworts. We have not found it. I don't know what the distribution map is in the country. In New York State, we found it in a number of areas along Lake Ontario, and it's been found in Oneida Lake. It can form fairly dense bottom coverage and can grow primarily in saline, deeper waters. This is what the plant looks like. It has these stars, if you will, along the joints, and it's one of the ways that you can help identify it. I'm not aware of any control strategies that have been used for, within New York State, at least, to control this plant, but I know a number of them, mechanical and otherwise, have been proposed. A few of the other plants to just keep on the radar screen, European water clover has been found in New York State. I don't know what the distribution of the plant is in New York State. And one of the reasons that it's worth mentioning is that it is a common aquaria plant, and that might be a means for its introduction, reintroduction, and spread in New York State. One of these plants that's been introduced from Europe. Water hyacinth has been found on Long Island. Native to Brazil, was introduced into this country in 1884 as part of the New Orleans Exposition. Tends to be found in shallow water systems. Very, very, very dense mass is found in the southern part of the country. If you believe the 2001 distribution map that's shown in the bottom part of the screen, New York is isolated relative to the rest of New England, which suggests it wasn't a spread but an introduction. However, again, one of the lessons that comes out of this is all these plants are very adaptable and can very easily work their way up the eastern seacoast and spread through lots of different means into New York State. Water lettuce has been found as part of the canal system near Buffalo. It was identified first in the United States in the 1700s in Florida. There is some evidence that suggests that it's not going to overwinter in New York State and therefore is going to be limited in its spread. But I can't emphasize enough that we keep relearning and relearning lessons about how these plants adapt and how they can ultimately spread. So again, another one to keep on the radar screen. And I think the last one that I'm going to mention here is Indian swampweed. Another one that's frequently cultured as an aquarium plant that has really been limited to Texas and Florida, at least as of a few years ago, but may ultimately get introduced in New York State, again, via the aquaria trade, because that's how it came into the United States. That's a whirlwind. Oh, I have one more, Asian swampweed, which was limited to, again, the southern part of the country. Again, another one that's worth mentioning because it was introduced via the aquaria trade. Last thing I want to talk about very briefly is inventories. The distribution maps that we've talked about are based in part on inventories that DEC Division of Water has been doing and a number of other people have been involved with. Just to give you a heads up on some of the places where we're going to be going to try to do some additional surveys is first some high exposure areas. We did a survey of Long Island in 2005 and 2006 that we want to follow up again this year to hit some of the water bodies that we didn't get a chance to look at that time, with a real focus on eastern Nassau County, where we found both water chestnut and Eurasian water milfoil for the first time in Long Island. We're going to do a fairly extensive survey with Parks and Rec and Harriman State Park because both Brazilian elodea and fanwort were found growing, particularly fanwort growing extensively in Harriman State Park, which was quite a surprise to the park managers and other folks who have been following the spread of fanwort. As many of you know, the Adirondack Park Invasive Plant Program has continued to be involved in an extensive park-wide evaluation of the Adirondacks. We're also, as part of our lake classification survey program, going to be looking in the Champlain Basin and the St. Lawrence Basin. And it's important to keep focusing on the Adirondacks because it might be an area where we can really make a difference, because many of these plants have not yet made their way into the Adirondacks. And it's an important lesson to remember that if we can catch these early and exturbate the populations early, we might be able to prevent the further spread of these plants. And then there are a number of other regions in the state where there have been limited surveys on at least some individual water bodies that we're going to be focusing some attention on. We extensively increased the inventory and surveillance in the Lake Erie and Niagara Basin region over the last 2 years. And over the next 3 years, we're going to be looking in more detail in the Chemung, Susquehanna, Delaware, and the Genesee River basins. The last call for coordination. One of the reasons that I was interested in making this conference call is to make people aware of our efforts to try to do some of this monitoring and to solicit requests for individual water bodies or places within different parts of the state that you would like to see survey work being done, whether we're going to be doing it or some other partner through the prisons may be doing it. I think this is a good opportunity through the Office of Invasive Species to try to coordinate as much of that as possible. I believe one of the previous presentations was about the invasive assessment protocol that Long Island, that was developed for Long Island, that I think has real promise for helping to prioritize some of our monitoring efforts and assessing some of the management activities that have been going on. I've been talking for 35 minutes.